Right. Okay, people, are you experiencing any lag or something? Because I feel like there's a lag this side. Man, if you're experiencing something, maybe a lag, just let me know, drop it down as quick as possible. Okay, right. The next one, the B part. Write down 2 benefits of cloud computing. Okay, what is cloud computing in the first place? Cloud computing is literally where you can actually do all these computing activities without really using it physically. What I mean by without really using it physically is if you can use internet, right? And if you can use internet and if you can make certain set of services or certain set of activities completed, right? Without using all your physical resources. That's what you call by cloud computing. So cloud computing is where you actually do not use your own resource. You're going to use someone else's resource, maybe someone else's server, right? Or someone else's application. Okay. You're going to use it without using your own resources, right? And that can only may be possible using something called the internet. So you being able to use someone else's resources via internet or through internet is what you call cloud computing. Benefits. What are the benefits of cloud computing? First one, uh, it can be cost effective. It definitely can be cost effective. Why do I say it can be cost effective? Is now not everyone over here would do graphic designing, right? Not everyone over here would do the graphic designing, and that is I mean you can never say that no one will ever do graphic designing also. Based on the situation, someone might have to do a graphic designing, someone might not. Okay, or for an example, someone might create a document, someone might not create a document. And let's say out of the 100 days of living, let's say 80% of the days you don't need to create a document, but in the 20% of days, let's say you need to create a document. When you are not someone who frequently uses a software, right? When you're not someone who frequently uses a specific app or a program or a service or a resource, you will necessarily do not need to purchase it. It's pointless purchasing it. If you're not someone who uses MS Word on a regular basis, putting on money and buying it is pointless. Instead, you can go to Google and type free online word processing software. You press enter, there'll be a lot of open source cloud-based software that will pop up. You can use it free of charge. Can you understand? So the first one is less costly, or you can say it's cost effective. The second one is you do not use your physical resources. Can you understand that? For an example, it saves a lot of physical space. Why I say this is we use something called Google Photos, right? Google Photos or Google Drive would give you the facility of a 15 GB storage space, right? Whereas your phone might not have enough storage space, right? Let's say you're using your phone to save, or let's say there are some other more important things to be stored on your phone. So in those situations, you can think, okay, fine. Let me put all these photos so that my phone can have enough space to do the rest of the other things. I'll put all the photos in a cloud service like the Google Drive or the Google Photos. This will ensure that your physical storage space is unaffected. Can you understand this? So these are 2 benefits that you can see. Okay, so the 2 benefits are, the first one is reduce cost. Okay, cost effectiveness is there. Second one is what do you call, reduce the usage of the physical storage space. Reduces the usage of physical storage space. 2 things. Another, there's a disadvantage also. There's a disadvantage also. Right? The disadvantages, you need internet. You definitely need internet. Without internet, you definitely can't do anything with cloud computing. Cloud computing is only possible with something called internet. And if there's no internet, you can't. Right? Requires internet connection. You obviously have to have all the computing resources also. Without a laptop, without a smartphone, you can't use cloud services. That is also there. Right? C. Look at the C. Write down the golden rule of information. What is the golden rule of information, people? Do you remember the chart? Do you remember we draw something like this? We draw a value to time graph, value and time. What do we profess here? What do we say here? What do we say? We say that the value of the information is at its peak. The value of the information is at its highest only at the point of creation. And with time, what happens? The value decreases. Right? The value of information is at its peak only at the moment of generation. At the moment it's generated is when it's in peak. After that, it slowly drops, okay, by time. That's the golden rule of information. So if you're going to write it down, what is going to be the answer? The value of information is at its peak only at the moment of creation. And the value would drop by time. So by time, what happens is the value of information would definitely drop. That's what you call the golden rule of information. The value of information is at its peak only at the moment of generation, and then by time the value of information would reduce. That's what you call the golden rule of information, right? Just a revision here. You all know this, right? Meanwhile, moving forward. Okay. Write down the three main steps of the fetch execute cycle in the order. There's this cycle called the fetch execute cycle. What is this cycle called? It's called the fetch execute cycle. What do you mean by the fetch execute cycle? Right. CPU along with the memory register. I mean, you know what CPU is. CPU obviously consists of three things inside. What are the three things that are inside? The CPU, ALU, memory registers, and the control unit. These three are already there. Out of these three, right, there's this main thing called the memory registers. Right? Memory registers and the control unit together would work together to fetch instructions. Right? After fetching the instructions that are there, right? I hope you know what an instruction is. Every program has a set of instructions. Every program has a set of instructions, and an instruction that is being executed is what you call a process. Every software, every program is a set of instructions, and when an instruction is being executed, that's what you call a process, right? So what actually happens in the fetch execute cycle is, first one is we fetch instructions. After fetching instructions, we decode instructions. It's necessary to decode instructions. You should know what that instruction is trying to tell you or to do. Decode instructions. After that, we execute the instructions. See, these are the three things that actually happens. We fetch instructions, we decode instructions, and then we execute the instructions that we decoded. As simple as that. Is that clear? They're pretty simple. Okay, the three main steps are in the fetch execute cycle. There are three things. That's one hidden step inside. That is decode. You fetch the instruction, then you decode the instruction, and then you execute the instruction. Right? That's what happens under the fetch execute cycle. And the second question. What's the second question here? Right. Second one, A. Write down 25 to the base 10 in 2's complement form of 8 bits. Hurry, try this out. The very basic thing that one student should be able to do 2027 or 2026. Trying to put things into 2's complement. Come on, give me the answer. Do it. Do it. I want all 14. Sorry, all 13. To get an answer from me. To get an answer from me. Come on. Use the chat box and try to get the answer here. Okay, how do you do 2's complement? How do you do 2's complement? The first thing that you do in 2's complement is, the very first thing that you do is simple. You check whether it's a positive or a negative value, right? If it's a positive value, nothing. Just convert and put it as it is. If it's a negative value is when you have to do all these unwanted things. What are the unwanted things? If it's a negative number, what should you do? You should invert it. Okay, upside down karanna ඕනේ. After inverting, what should you do? After inverting, add one bit. That is what you should be doing. As simple as that. As simple as that. Now, it's a positive number here. You don't need to worry about anything. You definitely don't need to worry about anything. What you're gonna do is just convert it as it is. So what should be the answer here? What should be the answer here? 25, right? You need a 16 bit, you need a 4, and then you need a you need a you need a 16, you need an 8 and 1. Right? So that's what you need. You need 1, right? 0, 0, 1, 1, 0, 1, 0, 1. This is what should be on. So Dhanushini has got the answer right. What about the others? Yeah, Vishudhara, right? Obviously. Vignesh, right? More people, nice. It's nice to see you people turning out. It's nice to see you people turning out. It's actually, I'm actually happy that you people turned out. I mean, even though it's 13 here, I expected more. But yeah, fine. Fine. Okay, 25, you should convert it into 2's complement, which means in binary. Binary, you should convert it to binary. And next one, minus 13. No, this is a negative number. It's a negative number. You can't do anything. You have to do all these unnecessary steps. What are the unnecessary steps that you have to do? Find plus 13, flip it. Find the plus 13 value in binary and then flip it. So plus 13 in binary is going to be what? You need 12 and 1, 8, 4 and 1. So 1, 2, 4 and 8. So and then 4 zeros. This is plus 13. What I wrote now is plus 13. You need to flip this. If you flip this, it will be 1, 1, 1, 1, 0, 0, 1, 0. And with this, you need to add one more bit. After inversing, we need to add one more bit. So it becomes 1, 1, 0, 0, 1, 1, 1, 1. This is going to be the answer here. Am I right? Got this right? Yep. Perfect. 3 ones. It should be 4 ones. Should be 4 ones. Okay. It should be 4 ones. Perfect. Nice. Okay. Dhanushri, that's correct. That's correct. Nice. Okay. Right. Okay, moving on to the next one. Pretty simple here. Simple cases here. So this would be big deals only if you are a 2027. Otherwise, it's actually simple for the 2026s. Right. How to get this? Yeah. Write down the value of 25 to the base 10 minus 13 to the base 10 in 2's complement form of 8 bits. Simple again. Okay, you know what is 25, right? You know what is 25. You know what is 25. What is 25? To get 25, you need 8, right? So you need 1, 2, 4, 8, 16. So 5 here, 1, 2, 3. With 25, you're going to add minus 13. We know the value of minus 13 also. What was the value that we got for minus 13? You got 1, 1, 1, 1, and then there's a 0, 0. So 1, 1. This is what you got as minus 13. So what you have to do is, you wrote the value for 25, you wrote the value for minus 13, and yeah, that's it. What you have to do is add. That's it. 1 and 1 in binary. 1, 1 is in decimal is 2. 2 in binary is going to be 0, 1. 1, 1 in binary. So in decimal is 2. In binary, it's going to be 0, 1. So 1 is 1 as it is. 1 is 1 as it is. 1 and 1 again is 0, 1 here. Right? 1 and 1 again is 2 in decimal. In binary, it's 0, 1. 1 and 1 again, 0, 1. 1 and 1 again, 0, 1. You get a ninth bit. People, tell me, ninth bit, what should we do? What should we do with the ninth bit? The ninth bit should be, if there's a ninth bit in in 2's complement, obviously you have to ignore it. Ignore the bit. If there's a ninth bit, ignore it. And this is going to be the answer. As simple as that. Okay. Okay. You just have to ignore the bit. Right. The next one. Give two advantages of 2's complement method. Give two advantages of 2's complement method. Give two advantages of 2's complement method. Okay. What are the two advantages of 2's complement method? Advantages. The first one is what? All your all your calculations would definitely go right. Very accurate. Right? And the second advantage is yeah, and the second advantage is going to be you have a better range of values that you can represent. What's the range of values? Plus 255 to minus 225, you can completely represent the whole range. So those are the two advantages. What are the two advantages? The first one in 2's complement, the first advantage is it's a better way of doing calculations because it's going to go right maximum. The second one is you can represent a larger set of values, right? Starting from a minus 255 up to a plus 255. You can represent both. So those are the two advantages. Okay, right. The next one. The next one, the most favorite, even if it's a 2027 or a 2026. Simplification. Yeah, 0 has one value. That's also right. That's also another advantage. Obviously, 0 has only one value. When it comes to 1's complement and 2's complement, sorry, 1's complement and the sign and magnitude, 0 will have two values. Here, 0 has only one value. That's also going to be an advantage. Nice. Good. Moving towards the B part. Consider the following Boolean expression in sum of product standard. Okay, Boolean expressions are of two types. There are two types of expressions. Product of sum expressions के लिए there's something called sum of products expression. Right? Product of sum would focus on the number 0. Sum of products would focus on the value 1. 0 volt we call it max term, and 1 volt we call it the min term. Okay? Right? So this is a sum of products expression. What do you mean by that? It means that this value would be equivalent to, this expression would be equivalent to the value 1. Which means they have got this expression by looking at all the outputs of the truth table that have given the output of 1. I don't know whether you remember this, people, but we can actually pull out a Boolean expression from a truth table. By looking at the truth table, we can pull out Boolean expression, right? If we focus on the outputs, where the outputs are zeros, you are going to pull out the product of sum expression. Okay, by looking only at the zeros மட்டும் பார்த்து நீ ஒரு expression pull off பண்ணீங்கன்னா, output zeros category மட்டும் பார்த்து pull off பண்ணீங்கன்னா, you're going to pull off a product of sum, right? அதே நேரத்துல if you look at all the ones of the truth table as outputs and அதுல இருந்து நீங்க ஒரு expression pull off பண்ணீங்கன்னா, it's going to be a sum of products. As simple as that. Okay, so that's actually the difference. That's actually the difference. Here we are pulling off a sum of products, which means we have looked at all the outputs that are ones and we have pulled the Boolean expression. As simple as that. Is this clear? Is this clear? I hope this is clear. Okay, simplify this Boolean expression using a Karnaugh map. Nice, let's draw a Karnaugh map then. How do you draw a Karnaugh map? What's the first thing that is supposed to be done, people? Can you all tell me? Can you all tell me the first thing that's supposed to be done? The very first thing that's supposed to be done? Okay, we learned this in detail. The very first thing. The very first thing. Come on, people. What should you do? Karnaugh map. Very first thing that you should do is what? You should be, you should be identifying. Hello, anyone? You should be identifying. You should be identifying. There's a message. Inputs, exactly. Perfect. Perfect. It's the inputs. The number of inputs. Uh, Give me a minute. Right. So you're gonna figure out the inputs. Okay, what are the inputs that we have here? The inputs that we have here are one is A, the other one is B, the other one is C. Figure out this. After figuring out this, we have to do a grouping in terms of these terms. Right? 2 by 2. Either as AB or A alone and as BC. Right? You're going to leave one out alone and take two into one group, right? And that's how you're going to do it because there are only three inputs. You can only group in terms of twos, right? So you will have to do this. The term that you have grouped in terms of twos, according to three inputs, would be taken as the column. So BC is going to be the column. A is going to be taken as the row. So I'm going to take this. I can also choose this if I want this, but I don't want this. I'm going to choose only this. So I'm going to take A to be my row and BC to be my columns. Okay. A to be my row, right? BC to be my columns. Okay. A is one input. To find the number of rows, we need to take 1 and power it with 2. So 2 to the power 1 is going to be 2. Therefore, you need 2 rows. 1, 2 rows. Here you have 2 inputs as columns. To find the number of columns, you should do 2 to the power 2 because it's 2 inputs. 2 to the power 2 is going to be 4. So 4 columns. 1, 2, 3, and 4. Okay, na? So 4 columns. And A is 1 input. 2 to the power 1, 2 rows. Okay. And then you have to mark the logical values. So this is going to be 0. This is going to be 1. When you're marking the columns, you know how to mark it. 0, 0, 0, 1. You can change only one thing at a time. 0, 0, 0, 1, 1, 1, 1, 0, 0. You feel this? Okay. Okay. After this, you have to do one more important thing, which is labeling these rows and columns based on the logical value that is there. Now, we are trying to use what type of an expression? We are trying to use a sum of products expression. And sum of products expression would always want the value to be 1. Which means we have labeled these logical values, right? If it's a sum of products expression that you're trying to simplify, when you're labeling these, the labels would also should be equal to 1. What do I mean by that? Have a look at this. Now, this is a 0 here at the row A. At the row A, what you get to see is a 0 here, right? But what we are trying to simplify is the sum of products expression, which is very much addicted towards the value called 1. அப்ப 0 இருக்க places எல்லாமே 1 மாதிரி act பண்ண வைக்கணும். You have to make zeros act like the values 1, which means இத A ன்னு எழுதிட்டு இது A இருந்தா இது 0. அப்ப இது 1 ஆக்குறதுக்கு என்ன பண்ணணும்? To make it 1, what should you do? Should make it A bar. Here the value is 1. So if A is 1, it can be as it is. Look at the BC here. Look at the BC here. I think I'll have to erase this. I think I'll have to erase this here. Erase this here. Yes, right. Here you have two zeros. You have two zeros here, right? Two zeros is not what you want in sum of products. We want them to be acting like ones. So this is going to be B bar C bar here. This is going to be B bar C here, right? Uh, these both are ones here. Therefore, this is going to be B C here, right? And over here, this is going to be B, and at the place of C, you have a zero. Therefore, you're going to make it C bar. Okay, I'll go this here. Okay. Now look at the expressions. Now look at the expressions. Okay, in the expression, the first thing that you have here is what? A bar, B, C bar. A bar, B, C bar. Okay, try to find this. Try to match this. Where is A bar? A bar is just over my head. Yeah. A bar is going to be this over here. A bar, A bar, and then you have B, C bar. A bar means this row, and then B, C bar is this column. So this row and this column, which is this. A bar row and B C bar column, which means so this is going to be a 1 here. Look at the expression, map it and fill it with ones. Next one you have A bar BC. Again, A bar is this row. Search the A bar row, fix the A bar row. A bar BC. A bar BC is this. And you have A B C bar. So A is the second row. A B C bar. Where is B C bar? A B C bar is here. This is a 1. And the next one, ABC. Okay, A the second column, BC is the A is the second row, BC is the third column, which is this. ABC, and what do you have next? What do you have next? You have A B bar C. What do you have? A B bar C. A, that is B bar C. A B bar C. A is the second row, and B bar C is the second column. Second row, second column is this. This is what we get. That's what we get. Have a look at this. Karnaugh map is filled. And zeros, you can omit them if you want. Or you can fill it also. It's up to you. But this is about sum of products. Let's do the grouping now. Whenever you group, you should try to group as large as possible. Right? Whenever you group, you have to group it as large as possible. And it should be in the powers of, it should be either 2s or 4s or 8s or 16s that you're grouping. Large as possible. And it should be in the terms of 2s, 4s, 8s, 16s that you're grouping. And the next thing is, you can do something called overlapping and you can do something called wrap around. Okay. Okay, firstly, the largest group that you can ever create here, group here is this, according to me. Would you agree? Would you all agree, people? Would you all agree, people? This would be the largest grouping that I can ever create. The largest of groupings. Okay, the largest of groupings I can ever create. This is one grouping. Okay, this is one grouping. And there's this one that's alone. There's this one that's alone. And I told you when you're grouping, you have to group it in terms of 2s, 4s, 8s, and 16s. And this one is alone. Can you have it alone? Can you leave it alone? No, you can't. You at least have to you at least have to have 2. So what you're going to do is, I'm going to group these two by overlapping. Agree. Got this right? Anything that's confusing here? Come on, people. All good, no? Got the expression. What should be the expression? What could be the expression? Over here. Right, the first one, the whole set. The whole set over here. Have a look at the whole set over here. Have a look at the whole set over here. Right. This whole set you have grouped. Right. If you look at the whole set they've grouped here, you'll be able to identify that you have grouped 2 columns and 2 rows. Right. You have grouped both A bar and A as a row, and you've grouped the columns B, C and B, C bar, both. Okay. Now, when you focus here, you have to be writing the row in lots of you write expressions, and you have to write the row that's in common and the column that's in common. Now, when you take this grouping, the large grouping that you have done here, can you actually tell one single row that this grouping would belong to? Is there any one single row that this group belongs to? Obviously, no. This group belongs to two rows, right? Two different rows, which means you can't fix on something, right? Here it's both the rows that are occupied. So when all the rows are occupied, all what you have to do is ignore that row. Just ignore that row. You don't have to decide on whether it's A bar or A that you have to write as the expression. Nothing. If both the rows have been considered here, you can't choose one also. Leave it as it is. But you can go ahead with the columns. If you look at the columns, you get to see that this grouping over here, what am I doing? Sorry. That this grouping over here is fortunately fortunately having one letter in common. You take the two columns over here. You have BC and BC bar. And in these two columns over here, what's common? What's the letter that's common? It's B that's common. C and C bar are changing. B is common. So what you do is when you're pulling off some product expression, when in terms of simplifying, it's B that you write for this grouping. Plus the other one over here, the smallest grouping over here. When you look at the smallest grouping over here, you get to see that the smallest grouping over here belongs to what row? Belongs to row A. So I'm going to write A. You can clearly see, right? You can clearly say, right, that this will belong to the row A. And yeah, and what column does it belong to? It belongs to two columns. So if it belongs to two columns, you're supposed to be selecting the common letter between the two columns. And the common letter is going to be what? B bar. Sorry, is it B bar? No, it's going to be what? It's going to be a C, isn't it? It's going to be C. So here C and C are common. Therefore, it's going to be C here. Right? So as per this grouping over the larger grouping over here, what we got was a B. As per the small grouping over here, what we got was AC. Therefore, this is the simplified expression of the sum of products. B plus AC. Yeah, correct. That's correct. AC plus B is also fine. Okay, na? So moving forward then, there's nothing else. There's nothing else. Let me move forward then. All good, na? Got this noted? Need more time to note this down? I don't think so. Right? You might have done this by now. Okay, erasing everything then. Erasing everything then. 3. Okay, 2, 1, and then yeah, done. Oh, yeah, they're all links. Okay, try that. Try that. Try that. The next one. Next one. Draw the logic circuit for the simplified Boolean expression using only and or not gates. Very simple. What was the expression that we got? We got B plus AC or AC plus B. Simple. A, B, C. Okay, firstly, what's happening? Let me make it very simple. AC. What do you mean by AC? AC means A and C have gone through the AND gate. If there is nothing in the middle, it's the AND gate. So A and C has to go through the AND gate. After going through the AND gate, you get A dot C here. With A dot C, B is joining towards A dot C and B are joined by what gate? There's a plus here. Plus means through and OR. That's it. A very difficult question. Okay. All good. Okay, understood. I hope things are clear. What have I done? Okay, and then moving forward. The next question. This is something that I haven't taught the 2027s yet in my class, but let me say this. Okay, there's something called the OSI 7-layer model. Okay, in networking or in data communication, you learn about something called the OSI 7-layer model. So these are 7 layers that in which you can actually categorize the protocols and the way these protocols are used. That is something called protocols that we use on the network in networks whenever you do data communication. So based on the protocols and how they work and their functionalities, you can categorize. So all the common functionalities and all the common places where these protocols or these rules work, based on that, you're going to categorize. That is OSI 7-layer. There are 7 layers. What are the 7 layers? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and there is another layer, the last layer, which is called the physical layer. Okay, right? So here are certain protocols, and you have to be writing the most relevant layer to these protocols. There's a protocol called the TCP/IP protocol. Now, TCP/IP protocol is a protocol that's used in what type of a layer? Come on, 2026. The 2026, can you all tell me under what type of a layer do we actually use TCP? Come on, people. Come on, people. Under what type of a layer? Under what type of a layer? Come on, come on, come on, come on. Under what type of a layer do we use? Under what type? Under what type? TCP/IP is used in the transport layer, right? Okay, transport layer. IMAP. IMAP is a protocol that's used in the okay, again once again. TCP is used in the transport layer. IMAP is used in the application layer. FTP, file transfer protocol, is again used in the application layer. IPs. IPs are used in the transport network. Yeah, it's used in the network layer. UDP. What about UDP? UDP is again used in the transport layer. HTTP again is used in the application layer. So transport, application, application, network, transport, application. That should be the order in which this is. Don't worry, we'll learn this in detail. This as a paper discussion right now. Okay. The next one. The next one. After this. Okay, let me erase this. Okay, moving on. Moving on. Fill in the blanks using the list given below. Right. Again, this list is a little confusing over here. Okay, let's give it up to y'all. Up to y'all. Okay, especially the 2026 should be able to type this out. Come on, people, I'm expecting you to give an answer. Try this out. Okay, have a look at this. Encryption and decryption are essential processes for securing digital information. Where encryption converts what to what? What to what? Encryption converts what to what? Encryption is a process where you convert all the plain text that you have into something called ciphertext. What do you do? Plain text is converted into something called ciphertext. Plain text are humanly understandable, whereas ciphertext is not human understandable. So encryption and decryption are essential processes for securing digital information, where encryption converts plain text into ciphertext using what? Using what? Algorithms and keys. Using algorithms and keys. Using algorithms and keys. And Decryption reverses the process to store the original data. Original data kiyanne plain text. To restore whatever the originality that it was from, which means going from ciphertext to plain text, is going to happen with decryption. There are two types of encryption. What are the two types of encryptions that we have? Symmetric and asymmetric. Symmetric encryption uses same keys. Okay, you're going to use both public keys in both the sides. For encryption and decryption, if you use public keys, you're going to be calling it as symmetric encryption. So symmetric encryption uses the same keys or same key for both encryption and decryption, requiring blank between parties. Requiring what? You have to do what? Since the same key is used, we should be doing something called a secure key sharing. So symmetric encryption uses the same key for both encryption and decryption, requiring secure key sharing. This is called secure key sharing between parties. Asymmetric encryption or public key encryption uses a blank. What does it use? In asymmetric encryption, in public key encryption, to encrypt, we use public key. To decrypt, we use the private key. There are two different keys. So since we're using two different keys, we're going to say it as a pair of keys. Right? Asymmetric or public key encryption uses a pair of keys. And then it says these encryption types are widely used to protect sensitive communications, secure online transactions, and ensure data privacy and regulatory compliance. That's the fill in the blanks. It's pure knowledge. Okay, the next one. Okay, odd parity, even parity, again a networking thing here. Again a networking thing here. Right. If a computer A sends the data 1010101, an even parity method is used to detect errors. Hurry people, the 2027s, 2026, you all know 27s. I haven't taught this, I'm introducing this to you. There are two error detection mechanisms. Okay. One is called odd parity. The other one is called even parity. What are the two parities that we have? Odd parity and even parity. Odd parity is where you make sure that whenever you're sending the data, your data will have only odd number of ones. How many? Odd number of ones. The number of ones that should be there is supposed to be odd. Okay. If it's even parity, we make sure that the number of ones that you send when you're sending as data has to be even number. That is even parity. So when you're counting the number of ones, it should be even. If it's even parity, if you count the number of ones, and if it's odd, it should be odd parity. For odd parity, it should be odd. Right. So here they are using what parity? Even parity. Normally, whenever you send data, you send it in the form of 8 bits. How many bits? 8 bits. What is the reason? The reason is 8 bits is what is equal to 1 byte. So normally when you're sending data, you send it in terms of 8 bits. Out of these 8 bits, people, are 8th bit on the 8th bit 8th bit I mean left hand side la irukka most left la irukka bit. So here if you look at this binary number here, what you have is 1010101. Itana irukka, how many bits do you have? You have only 7. But we actually use 8 bits. In the 1010101 la, this is what you have, right? In front is where we write the 8th bit. And this 8th bit is what you call parity bit. Sorry. Listen. And this parity bit is what will be used to detect whether your data has been transferred properly and accurately. Right? And if there is an error on the parity bit, that parity bit is what will depict whether there's an error or not. Parity bit, 8th bit. Now look at this. What are they using? An even parity method. Even parity method means the number of inputs, number of ones should be even. How many ones are already here? How many ones are already here, people? How many ones are already here, people? How many ones are already here? 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 The number of ones that are already here are 1, 2, 3, 4. There are 4 ones. Already 4 ones irukku. Right? Which means it's already in even parity. Number of ones even ஆத்தான் இருக்கு. There is no doubt about it. It's already in even. It's already in even. அப்ப parity bit 0 இருக்கணுமா 1 இருக்கணுமா? Just think. If I make the parity bit 1, what will happen? How many number of ones will we have? We'll have 5. 5 is odd. But we are sending it in what? Even parity. Can you understand that? Upper parity bit in our you should make the parity bit not 1, but you should send it with 0. This is what you call parity bit. Can you understand that? Okay. Parity bit whenever you're sending data, you're supposed to be sending data either using odd parity or even parity. ஏன்னா error detect பண்றது. For an example, if you want the data that you send to be as it is, so whatever you sent is what they received check பண்றதுக்கு you need to use an error detection mechanism. So odd parity, even parity is a mechanism. Right? So parity bit use பண்ணி தான் the odd parity or even parity and decide பண்ணிட்டு we send. Clear? So what is a parity bit? Right? The 8th bit of a data that is being transmitted is what you call as the parity bit. Right? And the 8th bit is used to determine whether it's an odd parity or an even parity. Can you understand that? Is that clear? So that is what is a parity bit. All good? All good. The 8th bit of a data that is being sent is what you call a parity bit. A parity bit is used in error detection as it is what determines whether it's an even parity or an odd parity. Okay? Okay? Right? Get this into your mind. Okay. If you want, get this noted. 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 What is a parity bit? The 8th bit of a data that is being sent. The 8th bit of a data that is being sent. The 8th bit of a data that is being sent. The 8th bit of a data that is being sent. The 8th bit of a data that is being sent is what you call the parity bit. And why do you need a parity bit? Why do you need a parity bit? I mean, obviously, to be to be in the sense, to understand whether there is error or not for error detection. 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 You call it error detection. For error detection. Sorry, tell me what the parity bit here should be. Even parity thane. So number of ones on the should be even, which means is the 8th bit also should be what? The 8th bit also should be, also should be 1 nil, it should be 0 because the number of ones are already even. Therefore, you don't need to make the 8th bit also 1. So you can leave it as a 0. So the 8th bit is going to be, the parity bit is going to be a 0. Give one constraint of parity bit method in detecting error. What's the problem? What's the problem of parity bit method in detecting error? First one, there is something called overheads. What do you mean by overheads? The overhead thing is error detection. Error detection is happening, but practically think. Let's say you're sending in even parity. Let's say you're sending in even. Let's say the number that you're sending is this 1101 000. So 4 ones, right? 4 ones, right? Which is even parity. Correct. But let's say this is what you sent. But what you received, let's say, is like this 1001101. Now you look at this. This is also in even parity, right? Or even number of ones. No? But just because this is in even parity, was this the same data that was sent? The data that was sent was this. But what you received was this. Just because both are in even parity, are they the same? No. That is the problem with the parity bit. right? And one more problem is not the parity bit method or the odd parity even parity method is not the most best method of error detection also. Can you understand that? So you call this uh, overheads. What do you call this? You call this overheads, right? Okay, note this down. The first constraint there, I'll give you two constraints. Know the first constraint. Know the first constraint. Can cause overheads in error detection. 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 Okay. Apart from this, the other problem can cause one is can cause overheads in error detection. The second constraint is it's okay. How can I say that? Uh, limits the value of data that can be sent. Limits the value of data that can be sent. That is also one more. Limits the value of data that can be sent. It limits the value of data that can be sent. Limits the value of data that can be sent. Because we are solely using the 8-bit as a parity bit. Right? We're not using it for any other reasons. Nothing. Nothing. Right? You could use it as some data collection mechanism. But no, that is not. You can use it to represent data, but unfortunately using it to uh, do error detection. That's a problem here. Okay, right. Moving forward with the fourth question then. Operating systems, nice. We just learned it. Operating system uses various ways to allocate spaces for files. Among those ways, when comparing with contiguous allocation, there are three types of allocations. What are the three allocations? Three allocations that we have are contiguous, linked allocation, and indexed allocation. Contiguous allocation, linked allocation, index allocation are the three file space allocation mechanisms. State two benefits of linked allocation. What are the two benefits that you can say regarding linked allocation? No external fragmentation. There is something called internal fragmentation and external fragmentation. There'll be no external fragmentation when it comes to linked allocation. No external fragmentation. And you can keep on increasing the file size. You can make, you call it file size can grow. What do you call it? You can say that the file size can grow. File size can grow. File size can grow. Yeah, correct. Point is they have to point the next process, the next block actually, and then no external fragmentation. Perfect, nice. That's correct. That's eventually correct. Okay. Meanwhile, state to disadvantages or limitations of linked allocation. State to disadvantages or limitations of linked allocation. What is the limitation here? Disadvantage or limitation? Now listen. A linked allocation inside one single block, you have something called what? Something called the pointer. Right? To store the pointer also the space that it takes. So you can say consume space to store the pointer, consumes space of the block to store the pointer, consumes space to store, so consumes the point, sorry, the pointer consumes space in the block. You can see something like that also. Anyways, the pointer is going to consume the space that's in the block. That is one. That's one disadvantage. Pointer consuming space in the block. That's one. And what's the second disadvantage when it comes to linked allocation? If there's a disadvantage, second disadvantage with linked allocation is going to be what? Yeah, on the linked allocation. Internal fragmentation can take place. There is no external fragmentation. But internal fragmentation can take. Internal fragmentation will definitely take place in all the three file allocation systems or allocation methods. Even in contiguous or linked or indexed, internal fragmentation will definitely happen. So the other limitation is internal fragmentation will take place. So it's a very normal thing. Very normal thing. It's very normal thing. Okay, right. The next one. Then operating system uses 7-state process transition model for process scheduling. Okay, 7 state, they're talking about 7 state. Current state of the process is ready state. So currently there's a process in the ready state. Fill in the blanks in the table given below appropriately. Right, currently there's a process in the ready state. Okay, so the current state is in the ready state. The previous state of the current state. What could have been the previous states of the current state? Now, current state is in the ready state. ഇത് എന്തെന്ത് സ്റ്റേറ്റ്സിൽ ഇരുന്നിരിക്കണം before coming to ready state. That is what you are right here. And the conditions for the state change. What could have been, or what could have happened for the state to change, right? Okay, ready state. Okay, there can be a process that can come from the ready suspend state to the ready state. You all agree with me, right? Okay, there can be process that can come from the ready suspend state to the ready state. So ready suspend. அப்படி இல்லைன்னா, or else there can be a process that came from the block state to the ready state. Okay, or else there can be a process that came from the new to the ready state directly. What else can I say? Running to ready. Running to ready. So from the running state also processes can come to the ready state. Okay, what can cause these transitions? Ready suspend இருந்து ready state க்கு வரதுக்கு என்ன transition நடக்கணும்? Come on people. Come on people, what's the transition that should happen from ready suspend to ready? From ready suspend to ready, what should be the transition that should actually take place? From ready suspend, so it's talking about the 7th state, right? From ready suspend to ready. Yeah, got an answer. What's the answer? Uh, no, ready suspend to ready. Ready suspend to ready. Ready suspend to ready. Activate. Activate should happen. Activate should happen. Blocked. What about the blocked? From block to ready state, what should happen? When IO completes is when something would go from the block state to the ready state. From new to the ready state, when will it go? When a process or a program enters. Running to ready. Running to ready will happen when there is a timeout. I hope you all remember this. Exactly. Right. People get me a minute. Get me a minute. Get me a minute. Okay, I'm here. Done. Right. Have a look at this. So this is what is here as of now. So these are the state transitions and whatever that could happen to make these transitions happen. I hope you understood the question, right? It's a very important thing to understand what the question is actually asking. Huh? And if you don't understand what the question is actually asking, then it's a problem. Read the question properly and you'll be able to. So, okay, let's finish these off. Part 2, part B, I don't think you'll be able to do it with the way you all are participating. Either no, one of the two will happen, but no. I'm not going to do the part B today. Let's do it on some other day. Have a look at this. State 2 disadvantages of contiguous memory allocation in the operating system. State 2 disadvantages of the contiguous memory allocation. Okay, what is contiguous memory allocation, people? When you're storing a file, if you are supposed to be, or if you're supposed to be selecting blocks that are one after the other sequentially in order to store that file, that's called contiguous allocation. An example, uh, if there's a hard disk, right, and if there are, let's say, 4 blocks, if you're supposed to select blocks that are one after the other, right, one after the other continuously, that's what you call contiguous allocation. Or a file is to open or to save a file. If you're supposed to be selecting blocks that are one after the other, if you, for an example, if you select block number 1, you should be selecting block number 2, 3, 4, something like that. You should go continuous. You can't be selecting block number 1, block number 5, 7, 8. You can't be going randomly. If you start with 1, you will have to choose the blocks that are after that sequentially. So that's contiguous allocation. What's the disadvantage of contiguous allocation? The first disadvantage is it will cause external fragmentation. That's the first disadvantage. External fragmentation. That's the first disadvantage. In contiguous memory allocation, the first disadvantage is external fragmentation. The second one is, you can say, internal fragmentation also. But file size can't grow, which means when you modify files, what will happen? Whenever you modify files, the file size will grow, right? Sometimes in contiguous allocation, you can't make it happen. The problem is, uh, it causes external fragmentation. Exactly. So since you can't eventually make a modification, since you can't do anything because of external fragmentation, your file size also can't grow. So that's the next disadvantage. Right. Look at the D part. Briefly describe the role of virtual memory in an operating system. What does a virtual memory actually do? Okay, I got a good answer. The memory space allocates a program in the hard disk temporarily when running out of the memory in the RAM. Perfect. That's exactly right. What do you mean by virtual memory? What is actually virtual memory as a concept? Right. The grade 12, it's the 2027s, we haven't started learning memory management yet. We'll be learning it not this week or the week after. But listen to this. There are two types of memories. Okay. One is the RAM, the primary memory, and the hard disk, which is the secondary memory. Two. Normally, the space that's available in the RAM is called the physical memory. What memory? Physical memory. Now, let's say your physical memory, which is your RAM space, is only about 4 GB. But you have a program that is of 6 GB that you have to run. But your physical memory space, which is your RAM space, is actually only 4 GB. The program is 6 GB. Can you run a 6 GB program in a 4 GB memory? In a 4 GB, what do you call, in a 4 GB physical memory? Can you? You can't. You can't. So what we do is, since the physical memory is only 4 GB and the program size is 6 GB, we would literally borrow memory from the secondary memory, which is the hard disk. We already have 4 GB. For the program to run, we need 2 GB more, and we'll take that 2 GB more from the hard disk. And whatever the memory that you borrowed from the hard disk, is what you call virtual memory. The memory that's borrowed from the hard disk in order to make sure that a program can run is what you call virtual memory. Right? So what is virtual memory? It is the process of what? Being able to, or it is the process of facilitating a larger program to be able to be run in a computer by using the space of the hard disk too. That is what you call virtual memory. Can you understand that? Can you understand that? So the 2 GB that you got from the hard disk is the virtual memory. And so what does the virtual memory allow you to do? The role of virtual memory is it allows you to run a program that is larger than the size of the physical memory. Right? So 4 GB RAM is what we had. But eventually 6 GB was the program. What did we do? We used the 4 GB of the physical and then 2 GB of the hard disk, which is the virtual memory. Can you understand that? So what's the role of a virtual memory? It allows you to run, or it allows the operating system to run a program that is larger than the size of the physical memory. Okay, what does it allow you to do? What does it do? It allows you to run, it allows you to run a program that is larger than the physical memory. Allows you to run a program that is larger than the physical memory. Allows you to run a program that is larger than the physical memory. Allows you to run a program that is larger than the physical memory. Okay? Okay? Right. So this is about all these part two. Oh, sorry, part two, part eight done. Number for this itself. Okay, all good, na? All fine, right? Pretty simple, pretty easy. It should be easy for the 2027s. I mean, you're starting off now, so shape kila I don't know. But yeah, should be. Because some of them we haven't learned yet. We didn't go towards data communication and networking as well. So yeah, fine. All right then. Shall we go towards part B? What do you say? Or is it enough? Right, let's see what's there in the part B. The paper is already there. Paper is already there. But in part B, what you have is, okay, you're only supposed to be choosing 2 questions, but let's discuss all 4. Oh, sorry, yeah, all 4, all three, yeah, all 3. Right, you have questions that are regarding logic gates here, Karnaugh maps, truth table. Okay, over here it's about pulling off logic circuits, Boolean expressions, drawing truth tables for these Boolean expressions, right? After that, you have about networking here, the characteristics of MAC address, right? The functions of the data link layer, advantages of star topology when compared to a mesh topology, the topologies are tested. And then here, Manchester signal encoding scheme. How do you draw the Manchester encoding scheme? I hope the 2026 are aware of this. Okay. And then the networking questions here, again, subnetting. Yeah, you have to be filling this table as usual here. And this one, the 7th one. Shall we discuss the 7th one? Shall we discuss the 7th one? Shall we finish off with the 7th one? We'll discuss the 7th one, we'll do the rest as well. I'm definitely going to do the rest of them, and it's going to be a regular thing. 7:30 to 9:30 or 7:30 to 9 is going to be a regular thing that's going to happen, especially for the 2026. I'm going to do this. Any doubts that they can come up or would face when doing questions would literally be discussed here. Apart from whatever we do in the class. So yeah, that is going to be the time that I'm going to allocate to you all hereafter. But yeah, the 7th question, have a look at this. Um, yeah, it should be every Wednesday, 7:30 to 9:30. That's how it's going to go. Yeah. Okay. Let's see this. Let's see this. If the block size of a hard disk is 4 KB, below is a portion of the file allocation table of the disk at a given time. Also, the area provides the blocks of the file named min.py. In this, the last block of the file is given as -1 and the directory of the file contains the block number of the first block of that file. Okay. Right. Now what we have is a file allocation table here, and this is what I'm talking about. Right. Roman number 1. What is the directory entry of the min.py? Have a look at this. It says the directory entry of the file contains the block number of the first block of the file. Okay. What is the directory entry? Where is the first block of the file? Can someone get this identified? Can someone get this identified? Okay, the place where, okay, you have 100, you have 101, 102, 103, 104. You have all these, right? Okay. The place where the first or the starting block is what you call the directory entry. For an example, I'm telling you, if 102 is the starting block of the file min.py, 100 is the directory entry. If 102 is the starting block of min.py, 100 is going to be called the directory. If 102 is the starting point, 100 is the directory. So you have to find the starting point. How do you find the starting point? Simple. You know the ending point. You follow the ending point. Look at the ending point. Ending point is -1. Where is -1? -1 is in 102. Which means someone has told that you have to be visiting 102. Okay, who has told that you have to visit 102? 102 is in block 100. Who has told that you have to visit 100? 100, okay, 100 was told to be visited by 101. Who has told you to visit 101? 103 has told you to visit 101. Who has told you to visit 103? Who has told you to visit 103? Has someone told you to visit 103? No, right? No, right? No one told 100 and no one told anyone. Okay, no block told you to visit 103, which means 103 is the block. That's the directory entry. What's the directory entry? 103. Can you understand what I'm trying to say? We have literally found the starting cell, the starting block. Can you understand what I'm trying to say? Come on, people. Yes or no? Yes or no? Yes or no? I want this answer. How many understood? How many did not? I need yeses and nos right now. Right now. Everyone. If it's a no, it's a no. If it's a no, it's a no. There's no issue with it. If it's a no, it's a no. Come on, people. I want all 13, sorry, all 12 over here to give me an answer. If it's a no, it's a no. What about the others? Okay. I'll repeat it once more. You're supposed to find the directory entry. Directory entry is the block that has the starting block. Okay. Directory entry is the block that has the starting block. Hurry. So directory, to find this directory entry, you have to find the starting block. But do we know the starting block? No. To know the starting block, we have to go with the ending block. That is what we know. What is the ending block? The block where that is -1 is the ending block. 102 is the ending block. Now, who told you to visit 102? 102 was told to be visited by 100. Why? Because 100 is what has 102. Clear? Who told you to visit 100? 100 was told to be visited by 101 because 100 is inside 101. Who told you to visit 101? 101 was told to be visited by 103. Who told you to visit 103? Anna, there is nothing. That is nothing. Which means 103 is supposed to be the directory entry. Why? Because 103 is what has the starting block. Next question. What is the space allocated for min.py? What is the space allocated for min.py? Tell me the number of blocks that is used for min.py. Tell me. How many blocks are used for min.py? How many blocks are used for min.py? How many blocks are used for min.py? Actually, exactly. Perfect, Mithura. That's correct. Come on, people. Come on, people, yeah. Got one right answer. எத்தனை blocks யூஸ் பண்ணோம் ஆக்சுவலாக இப்போ நாங்கள் ஒரு ஸ்னேக் மாதிரி அங்கெங்கேயும் கனெக்ட் பண்ணது எத்தனை blocks கனெக்ட் பண்ணோம் how many did we connect exactly correct it's 4 4 blocks தான் 4 blocks தான் யூஸ் பண்ணோம் exactly that's 4 blocks there exactly 101 101க்கு 103 இன்னொரு பிளாக் யூஸ் பண்ணோம் அப்புறம் 101க்கு அப்புறம் 100க்கு 101 ஒரு பிளாக் யூஸ் பண்ணோம் 102க்கு 100ங்கிற ஒரு பிளாக் யூஸ் பண்ணோம் -1க்கு 102ங்கிற பிளாக் யூஸ் பண்ணோம் which means we literally used how many blocks 4 blocks. What is the size of one block? One block is of 4 kb. The number of blocks that we used was 4 blocks. Therefore, the space allocated was how many kbs? 16 kb of space. Okay, na? Right? Right. Next one. Explain briefly with the help of 2 reasons why swapping is necessary in an operating system. Why do you need to swap in an operating system? Swapping எங்க நடக்கும்? Swapping எங்க நடக்கும்? Whenever there is, okay, whenever the physical space of the RAM is not enough, we do swapping. What's the first reason? RAM la irukka physical memory not enough. Now, whenever the space that's inside the RAM is not enough, we will do swapping. Can you understand that? Or else, to run a program that's larger than the physical memory, we will do swapping. What are the two things? What are the two things? First one, when there is no enough memory in the physical memory, which is the RAM, we will do swapping. Second reason is in order to run a larger program that's larger than the physical memory, we will use swapping. 2 reasons. I hope you understood the 2 reasons. See, compare and contrast internal fragmentation and external fragmentation used during memory allocation in an operating system. Right, simple. What's the difference between internal fragmentation and external fragmentation? We don't have anything to show, right, in terms of internal and external fragmentation. But what's the difference between internal fragmentation and the external fragmentation? Internal fragmentation என்னன்னா 5 kb space இருக்கு ஆனா நீங்க 1 kb மட்டும் தான் யூஸ் பண்றீங்க. That's called underutilization of the space available. When you have 5 kb of space, if you're using only 1 kb of space, that is underutilization of the block space. Underutilization of space is what you call internal fragmentation. சரியா? Space, okay, இருக்கிற ஸ்பேஸை ஒழுங்கா யூட்டிலைஸ் பண்ணலாம். Underutilization of the space that's available is what you call internal fragmentation. Okay, external fragmentation is where space இருந்தும் ஸ்டோர் பண்ண முடியாம போனா, that's external fragmentation. Underutilization of space is internal fragmentation. Okay, the inability to store even though there is enough space is external fragmentation. Can you understand the difference? Can you understand the difference? Can you understand the difference? Right. Internal is underutilization of space. External fragmentation is where inability or unable to store data. So inability to store data even though there is Space. Inability to store data even though there is space. There is space available actually. Okay, the D part. Compare and contrast physical memory and virtual memory in an operating system. Two comparisons are sufficient. Okay, simple. Physical memory and virtual memory. Physical memory is always the RAM. Virtual memory is always about the hard disk. Right? The other fancy thing is uh, physical memory is the memory space that's actually available. Virtual memory is the memory space that's actually borrowed. இதுவும் சொல்லலாம் இந்த டிஃபரன்ஸும் சொல்லலாம் physical memory வந்து temporary which is RAM whereas virtual memory is a permanent memory isn't it that is why we use it for swapping and all அதாங்க permanent இருக்க போது it will never get lost RAM will lose things right because it's temporary but virtual memory will never lose things losing of things will never happen okay did you note the differences physical memory and virtual memory you can say the first thing that you can say is physical memory is RAM virtual memory is about the hard disk that's one difference that you can say and apart from that what can you say uh, physical memory is obviously faster than the virtual memory. Virtual memory is slow, fast, permanent, temporary. And the difference சொல்லலாம். RAM is temporary, physical memory is temporary, whereas virtual memory is permanent. Yeah, that is what you can see. You can also talk about this. Through memory management, what do we do? Through memory management, we manage the RAM, right? We manage the hard disk through what management? File management. That is also a difference that you can talk about. Okay, so physical memory is managed through, which is RAM. RAM is managed through memory management, whereas virtual memory, which is hard disk, is managed through file management. That also can be difference. Okay, na? All good? All fine? Right? Sure? Okay, na? Any questions that you all want to raise? Is there anything that you all want me to? Yeah, this is correct. Rohan, your answer is correct. Perfect. That's right. That's right. That's right. Uh, any questions that you want to ask? Anything that's there to ask? Maybe based on the paper that we discussed today. I hope this brought you some insight. I hope it was useful. I hope I didn't waste the time that I took from y'all. That's one thing. I hope I didn't waste anything. Did I waste anything? All right. I hope I didn't waste. All fine. All good. Up until I haven't wasted your space. Up until this brought some worth into you. That's all what I want. Right then. That's it. If you all have anything to ask, maybe as a form of a doubt based on the discussion or anything else, you can stay back, ask. And that's it then. That's it then, people. Thank you for joining. God bless you. See you soon. That's it. Okay. Okay, thank you. Bye. God bless you. Bye bye. Bye, Riska. Bye. Bye, Dhanashini. Bye. Yeah, that's it then. Okay then. If there's nothing else, bye. God bless you. See you in the next class. Is there any doubt? Anything? The three here. Is it right? Bye bye. God bless you.